going to talk about a wiki which does not exist yet. We are just starting the design and implementation of it. So I'm in a good position so that I can talk about something that's going to happen. And as you see in the title slide, it's not called wiki, it's called database. This might surprise you, but on the other hand, Semantic MediaWiki is about structured data, so it's not too surprising. But the users are more looking forward to a system to manage their data, not so much into the wiki-based approach where everybody can change everything. So access control might play a role in the future as well. So I skipped the marketing slides and the why don't you see what I see? Okay, so the agenda for today is I'll present the project sponsor Kanton Zürich at the beginning and its goals and vision of the system. Then I'll talk 1 minute about the current state of the project and about the implementation, what we are going to do at the end. The project sponsor, as I said, is Kanton Zürich, more particular the Kantonale Denkmalpflege. They manage cultural heritage, monuments, buildings, parks, and farmhouses, and so on, from a data point of view. They maintain the registry, and they write documents about those buildings and so on. They consult people who want to renovate their buildings, for example, and say, no, you cannot remove this tower from your church because it's protected, right? So everybody can understand this. But on the other hand, if you're just owning a farmhouse, it might not be so clear what is allowed and what not. So this department helps people in giving advice where to go. Actually, there are 3 departments in this organization. The first department, documentation, is tasked with writing presentations about certain periods in the history of buildings or presentations or publications about certain areas or villages or so from an architectural cultural heritage point of view. Then there is this consulting department, what I just mentioned. They support owners or regions or cities in how to maintain buildings, what is allowed, what is not allowed, and what kind of windows to use in case there was a fire or something. And the last department is the inventory department, which basically collects all the data about the buildings and writes sheets about each individual monument or building. The goal of this project essentially is to replace a database which already exists. This is proprietary software built on a database, typical 2-tier architecture of the database, and on top of your database of your forms. That's how it's built right now. And the uptake of this database is not too good. So the members of the organization tend to avoid the database system if possible. They write their documents in their own format, they put it in the file share information in this way. Although a lot of functionality which are planned for the future system is already there in some way, but it's not ideal, and because of this, acceptance is low. So we tried to change this, and our experience with other projects, and probably your experience as well, is that a Semantic MediaWiki based system is easy to use. You can use your browser, you can click links, you connect objects with each other, and the metaphor of hypertext is everybody understands this. And the added benefit from Semantic MediaWiki is, okay, now you have your hypertext plus data and query possibilities. That's more or less what the people are looking for. And we are going to implement this data management system with Semantic MediaWiki, but leave out many things which are too similar to Wikipedia, let's say, like entering arbitrary wiki texts and everybody can change everything. This is not going to be part of the to be developed system. Instead of this, we'll have forms, and no one will ever see wiki text. So I'll show this later again. So there is data already, of course. The department is working since dozens of years already. They have many data records, dozens of thousands of records about their monuments. The same different data about the same monument is located in different locations even now, although there is a centralized data system already. They have many documents in file shares, and this is the data that they manage internally, that they create internally. And there are many images, and every day there are new images about those monuments coming in. They are managed in an image management system, and this is one of the upcoming challenges. This must be integrated somehow with the wiki or the Semantic MediaWiki based database. Geographic data is there. Maybe I have a slide for this. Wait a minute. Geographic data is there, and there's actually a whole service infrastructure provided by the Canton in Zurich for geographic information, displaying these things in web browsers, and publishing different kinds of layers and dozens of information layers on projected onto maps. Then there's external data like insurance information, which buildings are inhabited or not, and so on. Okay. And what we are supposed to do is to do it in this to achieve more or less the same goals as the old system, using new different technology where user acceptance is guaranteed. And the goal is to realize this system in a quite short time frame. We're talking about 4 to 5 months, including design, implementation, and acceptance. And the goal also is to have a user-friendly tool which works on mobile devices. If we're talking a web-based tool, this mostly is the case. I'm not sure whether semantic forms or stuff will work on all mobile devices, but data entry is not a requirement on mobile devices except for one use case. Another goal is to have something which is non-proprietary, so that there is a bigger developer community. You're not bound to a single vendor or so. And actually, do I have the same thing again later? Actually, the question is, of course, of interest in a conference like this one is, why are they going for a system, a database, which is based on Semantic MediaWiki? And these are some of the answers. Actually, I forgot to mention, one of the project sponsors is in the audience. Maybe you can wave, just in case I tell bullshit, please correct me. So one of the reason why Semantic MediaWiki is chosen as a platform for this database is MediaWiki is standard. It's a standard content management system, if you want, wiki system, web-based information system to some extent. It's free and open source. It's non-proprietary. That means you can go to rent a coder or something and find someone who works with MediaWiki, develops for MediaWiki, can even write templates or wiki text or so. So you're not bound to a small number of people in a company. So there are consultants and developers available. Many of them are here. And beyond MediaWiki, the reason why Semantic MediaWiki was chosen, because it's an ideal combination of text features and data features. Both are needed, and so it's a natural choice to have to choose Semantic MediaWiki. The data is explicit. like in a database, but now it's also explicit in the user interface, so that this explicit data makes it also very flexible. You can have different queries on the data and present them in different contexts in different ways. So different to Wikipedia, you do not need to copy and paste and reorganize your content in many ways. You enter the data in one place and present it in many places where necessary. And due to this flexibility based on the data, it's also better suited for future extensions. And another important reason for an SMW-based system was that once this system is built for the Canton Zurich, it might be shared with other cantons or cities or regions within Switzerland that have a similar problem. So the same solution can be taken and provided to other possible clients with small modifications, probably only. So currently we are in the middle of the so-called design phase, where we define the data model, where we design all the use cases, how people interact with the system. We look into the third-party systems, what kinds of data are there that we need to either migrate into the wiki or access at runtime or display in some way. The design, of course, also contains defining forms and reports, search pages, the menu structure, and so on. Of course, this is a generic slide now that I think about this. This probably holds true for most Semantic MediaWiki projects. And then in the design phase, we're also going to get the data in the current systems, get the documents in the current systems, and extract them to translate them in a format which is suitable for the wiki. Once this is done, we are going to implement some software, which means we are going to implement some extensions, PHP and JavaScript, and we are going to formalize the forms and reports and queries and so on, and many templates will be developed in this context. Now I gave you an overview of the project from a bird's eye perspective. Now let's look into a bit more detail, namely the data model. So if this says object here, object essentially means something like a building or monument or so. And actually this is the superclass, and the prototypical subclass of object is Bau or building. This is one house, one mill, or one farmhouse, or one castle or something. Another subclass of object is ensemble. An ensemble is a collection of buildings which belong to each other. For example, this could be the farmhouse plus the stables plus a well, or I don't know what. And buildings belong to ensembles. Not every building belongs to an ensemble, but an ensemble has at least one building. So this is the relationship. And then there are, whatever this is in English, parts of buildings. This could be equipment, yeah, or the organ in the church, for example. The big thing, it's a part of a building. And again, parts of buildings belong to buildings. So these are the three kinds of objects which are the central piece of the database. But okay, and here you can see some properties, if you want, of those objects. We have a schoolhouse here located at some address. This means city, zip code, street, whether it belongs to an ensemble or not, and which one. And this is the type of object and the title and so on. And there are many more properties for those things. Of course, you can also search for those things using some search pages, or a full text search will be available as well. So this now is extending the document, the diagram from the beginning. We have these three classes additionally, and they say Inventarbeschriebe, they are like the documentation more or less in text form of an object. So the object contains all the data with the zip code and insurance number and address, everything which is more data-like, and there are documentations for those objects, different kinds of documents, which contain a lot of texts explaining the history of a building, who built it, why was it built, and so on. And so this is like the heading of one of those documents, and then there are images and maps and explanations why a building has to be protected, a description where it actually is located, how it looks like, its history, many references to documents which explain something about the building, further documents, images, and so on. So this is describing objects in a static manner, I should say. Of course, they are not really static. For example, insurance numbers can change and so, but more or less this is static information. And on the right-hand side, there is more dynamic information. They are the journals which are written if one of the consultants was called up by an owner of a building, and the owner asks something about, I want to color my house, can I do this, and so on. And the consultants keep track of those information interchange with the people or with cities in their journals. As you can see, an object is connected to an object journal, and the journal has many entries. That's what it essentially says. And furthermore, an object journal can be structured. So there might be the painting of the facade, or maybe the destruction of a certain part, or so that the different kind of projects which are related to an object. So this can be filtered, or this is, in other words, there is the capability to assign journal entries to certain projects within one journal. This is how a journal looks like. Potentially, this is very simple. Actually, this is missing the project column still. And in this picture, you see that there are images and documents, and they are everywhere, essentially. Every object can be linked to documents and images. Every documentation of an object can be linked to documents and images, and even journal entries can be linked to documents and images. So when you look at this, okay, this is a kind of a complex data model for a wiki already, and this also poses some challenges which we are going to face. How are we going to implement this? And in terms of systems architecture, we are going to build upon MediaWiki 123, essentially because this is the most recent long-term support version, and one of the requirements is, okay, we must make sure that we buy a software which will work in the future as well. And this long-term support idea is quite well suited for company or organizational deployment where regular updates are not possible. So we'll stick to this one, and this will be around for the next 4 years, and in 4 years we can migrate to what, probably 127 at that time or something, which will be the next long-term support version. This says Semantic MediaWiki v2. Maybe we are going to use v2.1 depending on its release date, because we are probably not starting real implementation before December, so depends. Semantic forms and semantic forms input are probably also standard extensions working for a project like this. And semantic title, I'm not sure whether this is standard, but we definitely need this because there are so many objects, wiki pages in our system, so that we cannot give them a unique and meaningful name. We'll have to give them anonymous names and proper titles so that they can be linked. And for search purposes, we're going to use the enhanced retrieval extension, which is based on Apache Solr to support full text search. We're not going to use semantic maps because the Kanton Zürich has its own maps environment which we are supposed to use, and this is very powerful and only needs to be integrated. Okay, these are standard components, and of course we are going to implement a certain amount of software ourselves, some PHP extensions, some JavaScript, and probably skins will need to be developed by us. The challenges of this project, probably I mentioned all of them already. Nevertheless, so third-party systems and data is a challenge. This is not a standalone system which exists in isolation. In the contrary, there is a lot of data to be migrated into the system. There's a lot of data which still lives outside the system and must be interlinked in some way. For example, there are many documents which will be attached to objects or journal entries or so. Those documents are supposed to be available for full text search, and those documents and the result of this full text search is supposed to be linked back to the original wiki page or object or building at least. So this is posing a challenge. As I said, integration with the maps from Zurich is going to be a challenge. And maybe this is not a challenge, but I don't know how to call this. The users of the system are going to be of a non-technical kind. They are going to be architects, and they know about buildings. They know nothing about computer science, wiki technology, databases. So this is a real challenge, and we are going to tackle this by avoiding wiki markup everywhere. It's only visible under the hood. And data entry will only happen via forms and rich text editors, or WYSIWYG, as we heard in the morning. So this is the only way that users, except for super users, are going to interact with the system. There are also some requirements regarding document workflow, which is also a non-standard feature of MediaWiki and Semantic MediaWiki. Like we need to protect some pages, we need to protect some properties, so access control is important. Some of the documents have a life cycle, so we need to keep track of the different status of those documents. And there's even one requirement asking to be able to compare two different versions of a wiki page from a semantic point of view or from data point of view. So this is going to be one of the main challenges because it's nowhere visible in the main stack, in the main standard stack. So this is, for example, one of the requirements, or I said we need to protect properties. This is how it could look like in the solution. That means we have a report displaying one of those object documents, and some of the things cannot be disclosed to everyone, only to a certain audience, and the other people might see something like this, or they might not see this whole section altogether, which would be my preference, but we'll see. Software development that's going to happen is the access to the external data. I already talked about this. Document management system or file share, where many documents are currently located. They must be attached to the wiki. The GIS browser must be integrated. Actually, more or less all the challenges that I mentioned before are in this individual software development section as well. That means we have to find solutions for them. And a big part of our task is also to provide the data in many different formats which can be consumed downstream. So the KDP in Zurich is kind of a service provider. Their service is to manage the data and provide it to whoever needs this. And these are some formats that should be consumed by the customers of the KDP. New features that are going to be developed within the project is semantic forms input for choosing documents from a central file share or the document management system or the image management system, including probably things like a preview of the image before you actually link it to one of your wiki pages. And what happens in the background is we're copying the image into the wiki so that we can benefit from MediaWiki's metadata feature and thumbnailing and stuff. Wherever the image is available, it will be sized accordingly. When we link or import documents from other sources, we'll need to do a full text index of those documents so that the content of the document is available for search. We must combine this full text index with the object that this document is connected with. The GIS browser I already mentioned. It's very powerful. It can do a lot. It has a very expressive API as well. And this is a screenshot of the actual page. You can display many different kinds of maps here that you can choose on the left-hand side. You can have filters on the right-hand side. This is very complex. We don't need everything from here, but in different places of our system, we need different features of this GIS browser. For example, when someone creates a document for one of the buildings, she might want to integrate a certain kind of map in a certain place in the full text. And there she wants to choose which layer to display, the zoom factor, the exact position, which buildings to highlight, I don't know what. So this must be present in the editing workflow. So this is going to become a semantic form input, connecting the Zurich GIS browser with the wiki. And when visualizing or showing a wiki page, this interaction is either not possible at all for the authored documents, or very restricted. You might be able to zoom in or zoom out or drag and drop, but you might not be able to switch the layers or something. So the GIS browser is integrated in many places with slightly different kinds of features. Another new feature that is really required due to the non-technical users, we cannot expect them to enter boldface using 3 apostrophes or links with square brackets. We cannot expect them to do this. So instead we are going to implement a semantic form input which allows to integrate some rich text HTML editor. We are thinking about TinyMCE within a form so that we have a standard semantic form and there are sections for rich text where the user can enter tables and links to images and boldface and bullet points, whatever is needed there. So these editors actually are HTML editors, browser-based HTML editors, which store or return HTML, and we're going to store this HTML as it is within the wiki pages. Of course, there are some restrictions about the expressiveness, but I think we can manage this. So in other words, one of the results of this project will be a semantic form input for rich text. Maybe this is going to solve some of the WYSIWYG questions that we had in the beginning. That all? So this is essentially the end of my presentation. If you have any questions, lay them on me.
Yeah, just does the data is provided by the people from the government, or do you plan that some other people can read something if there is?
So this is a database system which is supposed to be used exactly by the people in the department, but there are plans to publish some of those data, because this is public data, to publish this on another system later, which might then be involved in a more wiki-like way. I'm just visioning something, so that people can upload their own pictures or something for a building which is actually described in a formal manner based on data from the KDP. But this is not part of this project.
Further questions?
If not, I have one.
Why do you think of creating a new rich text entry for forms and not using something like the wiki editor and making slight enhancements if required?
And does the wiki editor work with semantic forms?
Yes.
There's one wiki field at the bottom, so this is not a semantic form input.
We need text area. So, but anyway, so there is an editor already with a strong, let's say, usage base. And I know that every now and then there is discussion about creating a new editor here and there. And
okay, the wiki editor is going to add curly brackets and apostrophes into the text area, right?
Yeah.
Which is not possible for the user audience.
Okay. I'll just mention.
And the visual editor, or are you referring to the visual editor?
No, wiki.
Okay, the visual editor seems to be a future thing still, and no one knows when and if it's going to be compatible with semantic forms in some place. But if I may, I have a question for the audience, because Semantic MediaWiki conference is usually a discussion forum, a workshop more, at least in the past. So my question for you is, you've seen my complex data model with many connections between objects. Is there a best practice to change properties on other pages while you're editing a form? So the use case would be, I'm on an ensemble page and I want to add new buildings to this ensemble. This is natural use case, right? So I would have this. But also it's very natural to be on the building page and edit it and say, actually I'm part of a certain ensemble. So my model could look like this. It will not look like this, but it could look like this. So I can add buildings to ensembles, and I can add buildings to ensembles. In a standard way, I should only support one of those in one of the two forms. But from a user user's perspective, I want to have both. Is there a best practice to allow both? Does anyone know? Is the problem clear, or is it not clear? Okay, the problem is clear, but the solution is not. Okay.
Well, in general, it's better to let the child know who the
I know.
father is.
I know that.
But I mean, inverse properties, right? That would be one.
You cannot have inverse properties in forms. You cannot make inverse assertions or annotations, which would be like the ideal situation, yes. Or is it possible? That's one I know. Say it again?
I use both and then make sure that both are displayed. The trouble is when you get two different values for what should be the same thing.
Yeah, this is having both in a form is what I want, yes. But having it twice in the model, I don't want that. Okay, too bad. I have to come up with a solution myself. Okay, thank you very much.
Now you give us 10 seconds to think about it.
So,
Wait after the hiring.
yeah, sure. We have one more day, right? So
We'll have a solution at the hiring today.
okay. I hope it's not funny.
Just wanted to mention we've done something similar by SIOs, so which SIOs to point to. Now, we've done something similar to by using SIOs, semantic internal objects. So let semantic internal objects point to the very page you want to make them point to. It makes things a bit more complicated in some cases, but it works. For example, we have projects and we have subpages for projects, and on all subpages, like protocols for meetings or something, we can add persons to this project who were in this meeting, attended this meeting, and still via these SIOs you can query it that way, everything that points to that part. That might help. So
Okay, I didn't
just
get it, but I'll leave the link.
Well, the question really is, does it have to be inside one form? What I do is I have projects and I have tasks. So when I am at the project page, there is a form called to the task page actually that delivers the ID of the project to the task, so the task can be set up. And of course you can set up the task without being on the project page, so that would maybe...
I will have forms for ensembles and buildings. I will have forms for both. But the connection should be somehow possible to make on both forms. From a user's perspective, this completely makes sense.
On the ensemble form, you can have a link to the building form, for example, and pass the ensemble ID to the form. So you have to leave there. And on the building form,
you just enter.
You would just have to add the ensemble number or whatever. So
yeah, links would be a solution. Yeah, at least this keeps the model clear, which is appreciated. Okay, thank you very much.